So this is an equation we often use to calculate the distance of far off objects. So the variables we're going to be using is a small m, which is the apparent magnitude. I'm back on the screen. Apparent magnitude is, magnitude means the brightness that we see it. So apparent magnitude pretty much means the brightness as we see it from Earth. And then that'll be subtracted by big M, which is absolute magnitude. So for some celestial objects, we know how bright they are, like from a certain distance, from a distance of 10 parsecs. So yeah, from distance of 10 parsecs, we give it a magnitude value, or how bright it is. And this little a minus big M is going to equal 5 log to the base 10 distance. And this distance is also measured in parsecs. And you can read here, 1 parsec is approximately equal to 3.0567. I missed this 8, but you know what I mean. Just read it. Minus 5. And then there's something we have to consider called standard candles. And standard candles are the celestial objects where we know their absolute magnitude. So an example is a Cepheid star. So if we see another Cepheid star, we can calculate how far away it is by using the known absolute magnitude of one and then the apparent magnitude of one to find the distance in parsecs. So what we're going to be doing, a Cepheid star, a random Cepheid star from Earth has a magnitude of plus 4.2, and magnitude goes on a scale. It goes from positive 30, it's big. And then the absolute magnitude is, alright. Sorry. The absolute magnitude of a Cepheid star is minus 4.2, and the apparent one, which is us observing it from Earth, is positive 15.2. Alright. So with magnitude, it works on a scale that the smaller the number gets, the brighter the object is. And an increase of 1 magnitude is an increase of 100, the fifth root of 100 times brighter. So what we're going to do is now input the values into the equation to figure out how bright this apparent magnitude Cepheid star is. So we're going to go 15.2 minus 4.2 equals 5 log 10 d minus 5. Alright, so now that we've got that, what we're going to do is, well, this will add together. So I've got 19.4 equals this again. Plus 5. Then we can add this 5 across. 24.4 equals 5 log 10. Then the next bit we're going to do is we can divide both sides by this 5 here, making it 4.88 equals log 10 d. And the way logs work is 10 to the power of 4.88 is going to equal d. That's 9. And this, when we figure this out, we can find out the distance in parsecs, which is approximately 75,900 parsecs. So this gives us how far away the Cepheid star with the apparent magnitude of 15.2 is.